My name is Toby Kaplan. For more than 30 years, I was a classroom teacher and a mathematics coach. Now I work with Symphony Math. We're going to look at a routine today that will take 15 or 20 minutes of your class time, and it works with the whole class, small group. You can use it one-on-one, it works remotely, and it will also work with all the content in Symphony Math. The goal of the routine, in addition to the content, which today is Stage 14, Introduction to Fractions, is for students to take an active role in their learning of mathematics. We have students make models of problems and then talk about what they understand. And in this way, having students communicate and process what they think, students will gain a deeper understanding of mathematics, and we hope that they will also gain enjoyment in the math that they do. The big idea today is repeated equal groupings with parts to whole. This big idea is one of the most complex that students have seen so far. We know that fractions can often be confusing for students. It's a challenge for them, and when they don't understand what they're doing, they may resort to rules or rote procedures, and this isn't going to help them because we know that fractions are like an entry portal to algebraic thinking. They need a strong foundations for fractions. As they go on for the uses of fractions and decimal notation and percents and measurement and ratio and proportion, it's really important that this understanding is on a firm footing. And for that reason, we will use models. The visual models have a lot of emphasis as they learn about fractions. One of these models is the number line, which students have been using throughout the Symphony Math program and in their math classes. It's a good model to use for many reasons. It's a linear or measurement model. Students have prior experiences with working with whole numbers using this model. And it's a good way for students to understand the magnitude of fractions. Number line also allows students to count by fractions, and they're good counting numbers. In this way, we introduce them to unit fractions. Now, unit fractions have a 1 in the numerator, and students see how you combine unit fractions to make larger fractions, much in the same way they're used to combining units to make bigger numbers, units of ones, tens, hundreds. The number line also allows students to partition into equal parts. The other model we're going to use is the fraction bar. This is more of an area model, and we'll compare the two fractions for students to use. This is how I may introduce a task to students. Today we're going to look at numbers that are different than the whole numbers we've been used to looking at. These are called fraction numbers, and we're going to start by using a number line, which you're used to. But notice here, we're used to counting by ones or fives or hundreds. This number line starts at 0 and it only goes to 1. That means that the numbers we're going to be looking at today are less than 1. They're a part of 1. Now here's the task we have. On what number does the jumping dot land? Okay, it's going to land here. But first I have to know what are the fractional parts I've divided this whole line into. Well, I can count and see that I have 1 part, 2 part, 3 part, 4 parts, and that's how I get the denominator or the lower number of my fraction. I can see that there are 4 parts that this line is divided into, and we call them fourths. That's the denominator or lower number of a fraction. Each 1/4 is what we'll be counting by in order to figure out where the jumping dot lands. Let's do that. I'm going to count 1/4. There's a jump, and I'll label it so that I can keep track. There's 1/4. I'm not there yet. I'm going to count another 4th, and that brings me to a dot I'll label as 2/4. I count another 4th. So now I've counted 3 of these fourths, 1, 2, 3, and I've landed on the dot that is labeled 3/4. So the fourths make up the whole number, and we've used up 3 of those fourths, past 0. That's where the dot has landed. I'm going to show you another model, which we'll call a fraction bar, and I use that by taking this strip of paper, and you can see that this strip is the same length as this number bar. So I need to first divide it into the same number of parts as this number line, and that was 4 parts. So I'll begin by folding it in half. That's 2 parts. And I'll take my halves and fold them again. And that gives me 4 parts, which I hope are fairly equal. I'm going to make them a little darker so you can see them. Here's a part. Here's another part. Here's another fold. And so I have 1, 2, 3, 4 parts here, just like I do on my jumps. But this time, what I'll do is shade in the parts so that they match the jumps on the number line to see how much of this bar I've shaded in all together to match the number line. I'll start by shading in 1/4. That matches this jump. Let me shade in another 1/4, and that'll match up to this jump. I'll shade in another 1/4. So now we've shaded in 3/4 of this whole number bar, and I can see it lands on the same spot as this number line. So the jumping dot landed on 3/4, and the fraction bar shows the same amount of the number line. What do you notice? What else do you want to know? Ask students to take a few moments to think quietly before they share their ideas. Since you've asked them what they notice and what else they want to know, they can't be wrong. It's a safe environment for them to share their ideas. Now, their comments may not have to do with mathematics at first. They may comment on different colors. And that's okay, because you can turn that into a mathematical conversation. You might say, well, the first jump was a big jump and it was in green, but then why were there littler jumps of blue? As students are talking, you don't have to judge them or correct them, just let them talk. And to further the conversation, these are some questions that you can ask them. We used a number line when we worked with whole numbers. Now we're using a number line to think about fractions. How is the number line the same when we look at fractions? How is the number line different? Does the number line help you think about fractions? We see the fraction bar for the first time. What do you notice about the fraction bar? How is the fraction bar the same as the number line, and how are they different? In other words, we want students to attach meaning to the visual models that they see. Their understanding is not a fluent process. It may take them a while to get clarification on the ideas that we're presenting. So let's do a second task together. We have another problem. Here's a number line. Again, it goes from 0 to 1, and I see that it's divided into parts that are different than the first problem. So let me start by counting the parts. Here's 1, 2, 3 parts that are the same length. I want to be able to see how many jumps I'm going to need to get to here, because the question is, on what number does the jumping dot land? It's all the way over here at the end of this number line. So let's do that and label as we go. Here's 1 jump. And since we know that there are 3 jumps, and we call them thirds, I can label this 1/3. I'm not there yet, so let me take another jump and label that, and that would be 2 of those thirds. I'm still not here at the dot, so it takes another jump to get there. And that I will label, 3/3. So it took me 1/3, 1/3, 1/3. It took me 3 of those thirds to get to the end, and I see that, 3/3 has a 1 on it already. So 3/3 must be equal to 1 whole. I see I've jumped the length of the entire number line. So the jumping dot lands on a point that we call 3/3. Now let's see what that looks like if we use the fraction bar. Put this to the side, and let's line up a fraction bar, which again has the same length as this number line. But the first thing I need to do is fold it into 3 sections because I know I have thirds. Well, I'll make this as close as I can to 3 sections, and let's color in these lines so that you can see them more easily. Here's a third, here's a third, here's a third. All right, now just like these jumps, I want to shade in the parts until I get to this dot. Shade in this 1/3. Let me shade in this 1/3. That tells me I've got 2/3 shaded in, and I'll shade in the last third. So now I have 1, 2, 3/3 shaded in, and it's the whole bar that's shaded in. So the jumping dot lands at 3/3, and I can see that 3/3 is the whole thing, or equal to 1. What do you notice? What else do you want to know? Give students a chance to do some quiet thinking before they share their ideas. Now, some students may notice that they count up by 1/3, the unit fraction. Others may start to notice that, in fact, they're adding fractions. Don't rush them, don't push it. Students often say things before you have to tell them. And if you need to ask them some questions to get the thinking and talking to be mathematical, here are some ideas. What do jumps on the number line show you? What do the folds in the bar show you? How does the fraction bar match the number line? Both the number line and the fraction bar go from 0 to 1. Why does 1 have a fraction name? What does that name tell us? And after students have done some talking, let them know that you know they can do some tasks on their own. Tell them you expect them to make a model of the task and then talk about and be ready to justify their thinking. You can find many problems for the students to work on if you go to stages 14.1 to stage 14.3 in the guided practice. You can also go to the demo mode in the student program and click on the same stages in stage 14 and project problems on the smartboard for them. Give students 10 or so minutes to be thinking and talking and making models. And as they do so, you can walk around and be listening to them. That will inform what you want to do next. Now, after students have had 5-10 minutes to do some talking and modeling their ideas, give them space to ask questions. Again, you don't need to answer all these questions yourself. Let them talk. They may understand things and see things before you have to show them. When you're done, you want to debrief with students. Let them know that they've created fractions by dividing into equal parts a number line and a fraction bar. You began with fractions with 1 on top, and then you combined them, some of you added them, to get fractions with a bigger number on the top. But the bottom number, the denominator, stayed the same. This is in fact how you add fractions. And let them know they will have many more opportunities to practice this. As students go back onto Symphony Math Stage 13, you can monitor their progress by looking at your dashboard. If you go under the Use and Progress page, you'll see red, yellow, and green informative icons. And when you click on any of them, they'll let you know the particular tasks students could do without any problem, the ones they hesitated on, and then the ones that they were still stuck on.